So section 3.2. Let's check the first thing. If you remember, how we're gonna find the derivative or the slope. To find the derivative or the slope, we're just gonna use the limit process, okay? Which is the same thing. But now we're gonna find our rules to use instead of using the limit process. So the slope of the constant function, which is mean the slope, it's mean the derivative. The same thing. Now you're gonna see always d over dx. What does that mean? That's mean the slope with respect which variable? With respect to the x, which is mean the same thing, the derivative. I'm going to find the derivative with respect to which function, which variable? X. Because now when we extend that, it's going to be x and y, and you have to know if with respect to the x, like the derivative of t with respect to the x, or like the function t, the derivative to the y function with respect to the x. So no, it's the derivative, which is mean the same thing, the slope. Now I need to find the derivative with respect to the constant function. If you graph the constant function, it's going to be a straight line like this or here. This is the constant function at point C. Now we're going to use the limit process. The limit process, if you remember that, what we did on the previous class, we're going to find f x plus h. Keep in your mind, h is the same thing delta x. So because sometimes they're saying h instead of delta x, okay, which is the same thing delta x, because it's easier when you FOIL.
Well, it's easier.
It's easier, so you can use h, it's fine. Just if you got h, you're gonna say, okay, what's that mean? It's the same thing delta x. That means x plus the h with this function is going to be the same thing. Do you have an x with this function? Your function is f to the x equals c. That's mean you're gonna plug in the same thing because there is no x here.
Oh, I see.
So x plus h is going to be the same thing c. Remember what we did before? If you have f of x equal, let's say x squared, f to the x plus h is going to be x plus h squared, right? But now we have f of x equal a constant. So fx plus h also is going to be a constant. Now let's plug in using the limit to find out what's going to be the first rule. That's mean the derivative or d of x is going to be the limit when h approach to the 0, f to the x plus h minus f to the x divided by h. H is the same thing delta x, so don't get confused. So this one is going to be the limit when h approach to the 0, fx plus h is c minus f of x is the same thing c over h. Now c minus c is going to be 0. 0 divided by any number.
0.
You have to do to take the limit. That's mean f prime to the x is going to be 0. So here is the first rule. The first rule, every time when you take in the derivative to the constant function, the result equal
0.
every time. When you take in the limit for a number or constant function, the result is going to be 0. So this is the first rule. So now we're going to use this rule. We're not going to care about everything here. This is our rule. Every time when I'm taking the derivative for a constant function, the result is going to be 0. Now let's take the second rule. Can we do the same process? Now we have this function. F of x equal
X cubed.
x cubed. Let's take, we're going to do exactly the same thing. Now I'm going to use the limit process. That's mean f x plus h is going to be x plus h cubed. Yes or no? Let's use the limit. We need to find the derivative. So f of prime to the x is going to be equal. The limit when h, not x, h approach to the 0, going to be f x plus h minus f of the x, and everything divided by h. Again, don't confuse yourself. H is the same thing delta x. But sometimes when you're working on the examples, you will see h, sometimes you're going to see delta x. That's mean f of prime to the x is going to be the limit. It's going to be x plus h cubed minus x cubed divided by h. Now, let's FOIL this part on the side. We're going to say x minus h, x plus h, and x plus h, and x plus h.
Oh,
Because this one cubed, so I'm going to FOIL it on the side and bring back the result, okay? I'm going to FOIL these two, x times x, going to be x squared plus xh plus xh plus h squared, okay? Now here is x plus h. Let's FOIL this one again, but combine these together. So it's going to be x squared plus 2xh plus h squared. Then I'm going to FOIL x times x squared. It's going to be x cubed 2x plus 2x squared h. Be careful. 2x squared h. Then x h squared. FOIL the h is going to be plus h x squared. Let's flip these two. Because h times x squared, I'm just gonna write down h squared h 2x h squared, and this one, and a plus h cubed. Do we have like terms?
yes.
Here's x cubed. We have these two.
So it's 2x
No,
squared h.
this one similar. It's a plus of 3x squared h. This one similar to this one. So it's going to be 3x h squared plus h cubed. You see? So I did everything on the side. I'm going to just bring back the result. So it's going to be equal the limit h approaches 0. Write down x cubed plus 3x squared h plus 3x h squared plus h cubed. And everything is minus x cubed. Okay? Divide by h. Now what's the next step? Can I cancel this with this? Do I have h as a common? So it's going to be limit h approach to the 0. I'm going to take h as a common. 3x squared plus 3xh plus h squared. That's what the left. Divide by h. Cancel this h with the h. So what's the left? The limit h approach to the 0. 3x squared plus 3xh plus h squared. Now, if you take the limit when h approaches to 0, this one is going to be 0.
That's a little.
This one is going to be 0. What's the left?
3x squared.
Equal 3x squared. That's a really cool thing. Yeah, go ahead.
So is the easier way to do all that is just take the top, move it to the front, and then that one.
That's when we need to find. That's when we need to find, okay? So I did all these steps to show you it's the same thing when we do the limited process. So the rule, check what we found. Our function f of x equal x cubed. The derivative to the x is going to be equal. I'm taking the exponents here in the front, 3x squared, right? That's what we found. 3x squared. So check here what happened. The exponent moved to the front, and the exponent minus 1 is going to be 2. So that's the rule. So instead of doing the whole process, no, you're just going to use the rule. Every time when you have x cubed, to find the derivative, you're going to move the exponents to the front and the exponents minus 1. So let's write down the rule in general, because this is x cubed. The rule in general to find the derivative for function with n. With n exponents, okay? What's gonna happen? The exponent and x, just the exponents minus 1. So that's what we're gonna use. You don't have to go back and use the whole limited process. I'm showing you the limited process is going to be the same thing when you're using this rule. So that is going to be rule number 2. Okay? Now, the limit for constant is going to be 0. Sorry, the derivative for constant is going to be 0. And the derivative for any x to the power n, just write down the n, x n minus 1, okay? So now here's another rule. You can do the same thing, the limited process. If you try it on this one, it'll be the same thing. So rule number 3, if you have the derivative, c is a constant, okay, times a function. Constant times a function. So it's going to be the constant, the derivative of the function. That's it. How are we going to find the derivative of the function? If it's look like one of these, just find the derivative, then you're going to multiply the number with the constant. We're going to do examples, okay? The derivative of sine, cosine, and the exponential function. Derivative of the sine, what's the meaning of derivative?
Sorry?
What's meaning of the derivative?
Slope.
The slope, okay? The derivative of cosine is going to be negative sine. The derivative of the exponential function with nx is going to be n and the same function. Okay, we're going to take another example for this one. Now, this is really important. The derivative of two functions, addition or minus, is going to be the derivative for the first one plus or minus the derivative for the second one. Okay? And if they ask you the rate, the slope is the same thing, the rate, okay? Which is the change between x and y. So if they ask you find the rate of change, for example, if s is a position function, like this is with the physics, like velocity, time, and position function, okay? At the time t, then the rate is the derivative of the function, s function, with respect to the time, okay? So this is the rate of change. In case maybe not the section, the following one, they can ask you to find the rate of change. You're just gonna find the derivative with respect to the time, okay? So everything relates with the derivative. You have more than one option. Let's try to do some examples. These not from cosine, not from the notes. So the first thing, we need to find the derivative to 3. It's going to be what? Derivative for 3 is going to be 0. It's a constant. The derivative of negative 356 going to be what?
0.
So constant. The derivative of y is going to be what?
Also zero.
Also zero, it's a constant, 3.14, whatever, right? That's going to be zero. Keep this in your mind. The derivative of k pi, and k is a constant. Okay, so also it's going to be zero. Okay? Is that okay? Now let's check the other rule. We need to find the derivative of x to the power 6. It's not 6. This is 5. The derivative of x to the power 5 equal what? You see, we're gonna use rule number 2. The exponent is gonna move where? In the front here, so it's gonna be 5x, 5 minus 1. Oh, that's it. You don't have to use the limited process. That's the rule, okay? Find the derivative one over x squared. Do we have to? How are we gonna find the derivative for this one? There is a rule, we're gonna take it next section, how to find the derivative when it's rational, but not like this one. Tell me, do we have a rule, one of the exponents rule?
1 over 2x.
Yeah, 1 over 2x, because this is our function.
Mhm.
What are we gonna do?
Negative 2x.
That's the derivative, which is okay. But before that, one of the exponents rule, it says, talking about here, you have 1 over x to the power n is the same thing, x to the negative n. Okay? This is one of the exponents rule. So keep this one in your mind. And that's what I'm gonna do here. It's the same thing, this one equals the derivative of x to the negative 2. Yes or no? I'm not doing anything wrong, because this is exponents rule, so it's still right here. Now, can I find the derivative? But be careful. The derivative is going to be what? Here is the exponents.
-2 to -3.
Okay, here is the x, because -2 minus 1 is going to be -3. Now, can I bring back this -3 down? Yes or no?
What do you mean?
Like,
Yeah.
I have negative exponents, I'm gonna bring it back as a positive. So is that the same thing? -2 over x cubed? Yes or no? So this is the right solution. You can write down this, it's fine. But can I write down like this? It's gonna be also fine, okay? So this one, the derivative for 1 over x squared. The beach. Let's see what it is. Now, what about if we have y equal, let's say, okay, y equal x squared okay? It's the same thing using rule number 3. Constant times a function, okay? So to find the derivative, this is the y function. I'm gonna say, okay, it's the dy with respect to the x. That's mean the derivative of y function with respect to the x, okay? The derivative of y with respect to the x, which is mean the derivative. Here is the constant times d over dx to this function. This is the rule, okay? I'm using just the rule. So you can know. So it's gonna be, here is the constant 3. What's the derivative of x squared?
2x.
2x. Now 3 times 2, 6x. So you don't have to write down these. Okay, I'm just showing you, it's the same rule. It's the constant, the derivative of the function, okay? You just have to go from here to here. You're gonna say, okay, 2 times 3 is 6. Here is the x, 2 minus 1 is going to be 1. So you can just jump from here to here. You're just gonna say 2 times 3 is 6. And x, 2 minus 1 is going to be 1, okay? Let's do v over find the derivative in this manner. D over dx, and then pi over x cubed. How are we gonna find the derivative? We're gonna do the same process. Pi is a constant, okay? Sometimes they're gonna tell you pi is a constant, sometimes not. So that means you're gonna take this one equal pi out. It's the derivative of 1 over x cubed. Which is equal, here's pi. We're gonna say, okay, it's the derivative of x to the negative 3. Here's pi. What the derivative of this part is?
-3x to the -4.
You can just type it like this, -3 pi x to the -4, or you're gonna bring back the -2 down using the exponent rule. So it's gonna be -3 pi over x to the power 4. Is that hard? So let's see. So the first thing I have, they asked us to find the equation of the tangent line of the graph at the point x equal -2. Do I have the y? I need the point. I have the x. Do I have the y? There's no y. How are we gonna find the y? This is the easy part. How are we gonna find the y? For any graph, for any function, if you have the x,
Plug in
how are you gonna find the y? Just plug in the x here.
It's 4.
That's mean y equal, which is the same thing, f to the -2. That's mean -2 square, which is equal 4. That's mean the point is -2 and 4. So that's the easy part. So here, we need to find the equation of the tangent line. That means we need a point, and what's the other thing? We need a point and the slope, because we need to use this equations. Y minus y1 equal the slope x minus x1. We need to use this one. We have a point. We need the slope. Remember on the previous examples, we used to be doing the limit process to find the slope. Now we don't have to use the limit process because we have a rule. So our function, our graph is f of x equal x squared. The slope is, which is the derivative, right? Yes or no?
2x.
Which is 2x. So here's the x. Now, the slope at the point -2 and 4. How much the slope? At this point, how much the slope? Come on. This is the slope for the whole graph. I need the slope at this point. What are we gonna do?
2 times -2.
You're gonna plug in x here. That means the slope when x equal -2 is going to be 2 times -2, which is equal -4. You see, without losing the limit process. just these steps to find the slope. Now I have a slope, I have a point. Can I plug in everything here? So y minus y1 equal the slope x minus x1. That means y minus, be careful, 4 equal the slope is -4 x minus -2. That means y minus 4 equal -4 x plus 2. Distribute here. Y minus 4 equal -4x minus 8. We're just gonna move the 4 to the other side. That means going to be y minus -4x minus 4. But you're gonna add 4 here, you're gonna add 4 here, so it's going to be -4, okay? That's the equations of the tangent line at this point.
I have a question.
Yes.
So if y1 is -4, right? Wouldn't that be in parentheses when you're plugging it in? So wouldn't it make it y plus 4?
Yes, that's why I'm telling you, be careful. If, for this example, if this is -4,
Yeah.
so it's going to be y minus -4.
Okay.
Because this minus here with the equations. Okay?
Also, okay, I'm sorry, I thought y was positive.
No,
The
here it's
slope's
y positive,
Okay,
but if it's negative, like the x,
yeah,
check the x here, x minus with the formula.
yeah.
And x by itself, x1 is -2. It's be negative times negative positive. The same thing if you have a negative y, it's going to be plus y, okay?
Why did we have it? What, minus one?
That's
Because the
what I-
formula is minus y1.
Y.
Minus one.
So it's negative.
How much y1?
Oh, yeah,
Four.
oh, okay, 4.
4. Don't
That's
think
what I
you just
thought
said. Y is 4, but the slope is negative. Okay?
That's what I
You
thought
confused
too.
me when you
I
said
know,
that.
yeah, I'm sorry.
Seven over 3 x to the -2. We're gonna find the derivative.
Cool.
Yes, the same thing. Then I take 7 over 3 out as a fraction. So do the same thing. Okay, I'm gonna say 7 over 3. And the derivative of 1 over x. I'm telling you, you don't have to do these steps. I'm gonna go ahead, 7 over 3, the derivative for this part, okay? Which is equal 7 over 3 times, can I take this one up? Is that right? Because it's negative, when it goes up, it's going to be positive. So now it's going to be 7 over 3. I forgot it's the derivative for x squared. Going to be times 2x. What's the result is going to be? 14 over 3, and here's the x. Yes or no? You lost.
So why did it become 2x?
Because we need to find the derivative for x squared.
Oh, yeah.
2x, 2 minus 1 is going to be 1. Then these numbers, you can multiply it. So the same example, exactly the same example, and let's do a little change. D over dx, 7 over 3x to the -2. We can solve this one. It's the same example, but the -2 for the 3 and for the 3. Now, can I take 7 over 3 out?
No,
No, of course. Why? Because the 3x with the -2. Okay, but can you take everything down to the top?
yes,
It's going to be positive. That means This one, the same thing. Here is the 7, d over dx, 1 over 3x to the negative 2. Okay? Which is equal. Here is the 7, d over dx, it's 3x squared. Yes or no? Yes or no?
Yeah.
Why yes? Maybe it's wrong.
So bad.
Tell me
Cause you moved it to the top
why I'm moving it to the top.
to make it positive.
Yes, because I'm using one of the exponents rule. The exponents rule says you have 1 over a number with positive exponents or negative exponents. When you move everything to the top, there's going to be a to the positive exponent. It's just the opposite exponents, okay?
Mhm.
Because it's hard to work sometimes with the negative exponents. So we'll always move into the positive. Okay? We're gonna do the same thing. Here is 7 d over dx. Now I need to FOIL this one, not FOIL. 3 squared is 9 and x squared. Now, can I take the 9 out? Because it's a constant. So it's going to be 7 times 9 times the derivative of x squared. Okay? Which is equal 7 times 9. What's the derivative of x squared? What's the derivative here? 2x. Now, multiply these. 7 times 9. 63 times 2. So it's going to be 126x. Okay? And again, you don't have to put d over dx. You can just jump. You have to do this step, and then jump right away here. Like when you finish this step, 9x squared, then you can say, okay, 7 times 9 times 2x, and you can get it. But by practicing, we can do that right away.
Swerve, hard pass. We need to fix that.
Let's check this one. Can we do, what did you say?
Oh, I said what first week thing?
Which is the requirement.
Yeah, so
You're good, you're good.
any online class, you have to do the first week.
Let's check this example. How we gonna find the derivative of the y? Y equal 4x to the power 5 minus 6x squared plus 3x plus 16. That's mean the derivative dy with respect to the x. That's mean the derivative dy with respect to the x. We're gonna find the derivative by using rule number 4. The derivative for each part, okay? The derivative for the first term equal what? 4 times 5. 4 times 5,
20.
20. Here is x. 5 minus 1, 4. You see, you don't have to do d over dx. Let's go like this. Okay? Minus 6 times 2, 12. Here's the x. 2 minus 1, 1. Plus 3. X, 3 times 1, 3. 1 minus 1,
0.
that will be 0. So you don't have to write down the x. Okay? So it's going to be x, 0. Plus 16. What's the derivative for 16?
0.
So don't have to write down. That's it. You got it? So you don't have to write down d over dx every time you're trying to find the derivative. Just go ahead, find the derivative. Multiply 4 times 5, 20. 5 minus 1 is going to be 4. Minus 6 times 2 is going to be 12. 2 minus 1 is going to be x. Here's the problem thing. 3 times 1, 3. 1 minus 1 is going to be 0. X, 1 minus 1 is going to be x to the 0. How much x to the 0? No,
One.
1. Any variable, any number with exponent 0, it's going to be 1. This is one of the exponent rule. Any number with exponent 0 is going to be 1. Okay? That's why it's going to be 1. So 3 times 1 is going to be 3. And 16 is a constant, so the derivative is going to be 0. Let's do another one here. Y equal EX to the negative 5, 6x to the negative 3, plus 16x squared minus 3x. See? Can you do the same thing? D over dx is going to be equal. Tell me now. Go ahead.
Negative 15
Negative 15x,
to the power of 6.
negative 6.
Negative 6.
Come on. Negative 6 times negative 3
Negative 18.
Positive.
plus
Oh, yeah.
18. X, negative 3 minus 1,
Negative 4.
negative 4, plus 16 times 2,
32.
32.
x, 2 minus 1, 1, minus. Because x is going to be 1 minus 1, which is 0. X to the power 0 is going to be 1. So 3 times 1 is going to be 3. Got it? It's easier now. Need some chocolate cake? Y equal negative 3e to the 4x. Need to find the derivative. It's exponential function. You see the rule number 3? So the derivative dy over dx is going to be, here is negative 3 times what?
4.
Just the 4. Yes, just the 4. Okay, just the number here. So times 4, and you can add down the function exactly the same. Okay, that means dy over dx is going to be negative 3 times 4, negative 12, e to the 4x. You got it? Let's do these examples. We're gonna find the derivative. So how are we gonna find the derivative of 2 sine x? So 2 is a constant, so here is 2. What's the derivative of sine x? Here is the 2. What's the derivative of sine x?
Cosine X.
So it's gonna be 2 cosine. That's it. The derivative of x minus cosine x. Be careful here. What's the derivative of x?
1.
The derivative of x is going to be 1. Why it's 1? I'm talking the derivative for x. Why it's 1?
It's to the power of 1. You move the power forward.
Here is x.
So it's
And
x.
here is the exponents, and here is the coefficient 1, right? To find the derivative, here is the 1, x, 1 minus 1. So here is the 1, x to the exponent 0. That's mean 1, this 1 equal 1. 1 times 1 is going to be 1. Okay? So the derivative of x is going to be 1 minus. What's the derivative of cosine?
Negative sign.
So negative sine x. That means the result is going to be 1 plus sine x. Okay? Careful. Third one. What's the derivative of sine? It's
Cosine.
cosine x. Now, what's the derivative of e to the x?
E to the x.
The same thing. How much the number here? How much the number here? How much the number here?
1.
1. So that's mean you're gonna type 1 times the same function, okay? So 1 times any function, is that the same thing? Plus e to the x. Okay? Next one. Cosine x plus e to the 5x. What's the derivative of cosine? Negative sine x. What's the derivative of e to the 5x?
5e to 5x.
5e to the 5x. That's it. It's okay.
The y is gonna be 4, no?
So let's think about that, because that's the cool thing. At what point does this function have horizontal tangent line? So horizontal tangent line, that's the tricky part here. It's horizontal tangent line. What's that mean? Don't say it. What's that mean? Horizontal. What's that mean?
Slope is 0.
Perfect. So think it's a horizontal. Go ahead. If you graph any horizontal line like this, if you find the slope for this horizontal line is going to be 0. Okay. What about vertical line? Like a line like this. How much the slope?
Undefined.
Undefined. You have, well, it's a vertical asymptote. It's always undefined. The same thing, the slope with it is going to be undefined. So for the horizontal line, always the slope equals 0. For the vertical line, always the slope is undefined. Because if you pick any 2 points from the horizontal line with x, y, and with x, y, go ahead, just use the slope formula. y2 minus y1 over x2 minus x1, the slope is going to be 0. For the vertical line, the slope is going to be undefined. Or you're gonna find the derivative if you know the function here, the same thing. Now, the slope equals 0, which is mean the same thing. The derivative equal to what?
0.
Because the derivative is the same thing, the slope. Can I find the derivative? Yes or no? So I'm gonna find the derivative dy over dx, which is equal. Tell me the derivative for x cubed. X cubed,
3x squared.
3x squared, minus the derivative of 3x. That's the derivative of the function, which is mean the same thing, the slope. Right? Horizontal line, that means our slope equal 0. The slope is that mean the same thing, dy over dx equals 0. Yes or no? Go ahead.
Can we take multiple derivatives out?
Yeah, but we don't need the second derivative. We don't need it now. Okay? We just need one derivative. Okay? But if you take the second derivative, it's going to be slope. Okay? That's the first one. And now we need to focus. Horizontal, the slope equals 0. Does that mean dy over dx equals 0? So does that mean this part equals 0? Does that mean this part equals 0? 0 equals 3x squared minus 3. Yes or no? Now, can I solve this one? How are you going to solve it?
That's 3.
Add 3. Cancel. So 3 equal 3x squared. Then divide by,
3.
that's mean x squared equal 1. Now what I have to do?
Take the square root.
Take the square root of both sides. Square root of x squared equals square root of 1. That means x is going to be equal what?
1.
Okay. What's the square root of 1?
Positive, negative.
Don't forget that. Always plus minus 1. Okay. They tell you at what points, that's mean more than 1 point. 2 or 3, but now how many x? 2, that's mean we have 2 points. So did we finish?
No.
No,
So when x equal 1, how are we gonna find the y?
we plug it in
Plug it in.
Where, here or here?
on the first,
On the first one, that's mean y is going to be equal 1 cubed minus 3 times 1 plus 4. 1 cubed 1 minus 3. 1 minus 3 negative 2 plus 4 2.
Two.
That's mean 1 and 2. This is the first point. When x equal negative 1, y is going to be negative 1 cubed minus 3 times negative 1 minus 4. It's plus 4. Negative 1 cubed is negative 1. Negative 3 times negative 1 is going to be plus 3 plus 4. Y is going to be 7 minus 1 is going to be 6. Negative 1. So at these 2 points, the slope has what? Horizontal line and the slope equal
0.
0. That is just the opposite thing. You get like this example when you're doing the example from what design. Now think about that. So I'm gonna find the derivative. Okay? dy over 3x equal 3x squared plus 6. So horizontal tangent line, that's mean our slope equals 0. Slope equals 0, which mean dy over dx equals 0. So that's mean this side equals 0. 0 equal 3x squared plus 6. How are we gonna solve this one? Minus 6. Cancel. So negative 6 equal 3x squared. Divide by 3. That's mean x squared equal negative 2. What's the next step?
Square root, but
For both sides.
that being like imaginary numbers.
Okay, square root of x squared. So it will be x equal plus or minus
I. Or
square root of 2i. Or minus square root of 2i. So do you have points?
No,
That means there's no point. Because always this part always greater than 0. If you picked any number with x, always going to be greater than 0, okay? And you will see the number of x is an imaginary number, so that means there is no points, okay? Got it?
got it.
Subtracted cake.